Today we want to study mathematics, right? In this class we need to study mathematics. But before studying mathematics, let's finish this part. Okay? So can you take your chemistry notebooks? Am I audible?
Sir, can we continue chemistry
Yeah, we can continue chemistry.
today, like
Yes.
right now?
Yes. After finishing this 2.1, we can move to mathematics.
I want to complete 2.2 also.
Sorry?
I want to complete 2.2 also.
Right. Now you can hear me and right. Now it's okay, I think.
Uh,
Is it okay now?
uh, I can't see your video. It's just black. I can't see.
Now?
No, your video. I can't see the video.
Now also you can't see the video?
No, I can see now. Yeah, it's
Now you can see.
yeah.
Right. Okay. Um, right. We were discussing about solutions and mixtures, right?
Yes.
Where is the page? Can you tell me the page number so that I can easily take the page? Page number
Page number 12.
12. Page number 12. It's causing some troubles. Which screen you can see?
I can't see the screen. Now your video is off.
My video is off now.
Now I can only see black. It's just black.
What about now?
I can see the video.
Now you can see the video. Can you see two videos?
I can only see one video.
One video. Okay, if I stop it. Right, now I'm going to share the screen. Wait, wait. Open this PDF. Right. Hope you can see the screen now. You can see the screen now?
I can see the screen now.
Yes, so both video and screen are visible.
Now I can't see the video, but I can see the screen.
Why? Okay, I will not share the screen. You can see your book. Okay? Right. When I stop the screen sharing, you can be able to see my video.
Is your video on?
Yes?
Because I can't see the video. I can't see your video and screen. Now.
Now you can see the video?
No, I can't see the video now. I can only see a picture and nothing.
Now?
Now I can see the video.
You can see the video now. Right.
Yeah.
Right. Okay. Right. Page number?
12.
Right. Mixture, solution and solvents. Okay. We studied mixtures. So we divided mixtures into two portions. One is homogeneous mixture and the second one is heterogeneous mixture. You understood the differences between homogeneous and heterogeneous mixtures, right? So normally homogeneous mixtures are called solution. So in a solution there will be two components. One is solute and the other one is solvent. So solvents are usually liquid and this solute can be liquid, solid or gas, anything. Okay, gas, anything. So usually solvent is liquid, but solute you can dissolve liquid into a liquid. Okay, so you can dissolve alcohol into the water. You can dissolve a solid. Sometimes you can solid means you can dissolve salt into liquid, into water, and sometimes you can dissolve gas also. Do you know soda? Have you drunk soda?
Yes.
So soda, we dissolve carbon dioxide into the water under high pressure. So gas is dissolved in soda. Carbon dioxide is dissolved in soda. That's why you observe some bubbles into the soda. Okay. Right. Now solutions. Solution. When you make sugar with water, the sugar seems to disappear. That is because its particles spread through the water particles. I already explained that. Okay. Now solute plus solvent is equal to solution. Okay. In the book they have given an example like this. Solute plus solvent is equal to solution. Okay, so that means in a solution there are solvent and solute. Okay, right. Now not everything dissolves so easily. Okay, you can dissolve sugar into water, but if you dissolve chalk into water, will it dissolve? No, because you take some amount of water, you put a chalk inside the water, right? After that it will be precipitated. Okay, it will be precipitated, so it doesn't dissolve. So not everything dissolves so easily. Okay, right. You can see the picture here, a mixture of chalk powder and water. This is not a solution because it has not dissolved in the water. That's why we don't call it solution. Okay, right. Chalk particles do not spread through the water particles. They stay in cluster big enough to see in time. Most sink to the bottom. Right. chalk will sink to the bottom. So that's why we call precipitate. It will be precipitated, right? Right. Now you can get it out by filtering, right? If you after putting the, right, you put a chalk inside the water. After that you stir it. It will dissolve. It will be, if you put a chunk of chalk, it will become powder. At the bottom it will become like powder.
Yeah.
Right? After that you can filter the system and separate the chalk. So it is not a solution. Okay? You got the point?
Yeah.
Yes. Why is it right? Now think about chalk. If you mix chalk powder with water, most of the powder eventually sinks to the bottom. You can get it out again by filtering. They tell after filtering you can get the chalk. Right? Why is it so different for sugar and chalk? Because their particles are very different. Because the particles in which this chalk is made up of is different from the particles in which sugar is made up of. So the particles made up of sugar has the tendency to dissolve in water, but it's not the case for the chalk particles. So that's why the chalk doesn't dissolve in the water. Okay? Understood? Yes. Right. Because their particles are very different. How easily a substance dissolves depends on the particles in it. So, depending on the particles, only we can say the solubility of a substance. Okay? Look at the examples in the table. Okay? They have given some examples. Okay? Silver nitrate, calcium nitrate, sugar, potassium nitrate, potassium sulfate, calcium hydroxide, calcium carbonate, silver chloride. They have given some compounds. In the next column, they have given mass dissolving in 100 gram of water at 25 degrees Celsius. Okay, so the case is, do you want to write anything?
Yeah.
Shall I erase?
Yeah. Your video is step, right? It's just step. Are you writing?
Now? No, I am not writing anything. Can you see my hand?
Okay.
Yes.
Yeah. Yeah, now.
Shall I erase?
Yeah.
Okay. Right. You take 100 gram of water in a beaker. Okay. So here we have taken some amount of water. The mass is 100 gram of water. Okay. Right. The temperature is T is equal to 25 degrees Celsius because solubility of a particular substance depends on temperature. So that's why we take a particular temperature. Okay. In different temperature, the solubility will vary. You know, right? You take 3 glasses. Okay, 3 glasses. In this glass, you have cool water, cold water. Okay, cold water. You can demonstrate it in your home. You take cold water. Okay, from the fridge, you can take some cold water. After that, you can take some normal water. And hot water. Okay, hot water, and the amount of water should be same. Okay, the amount of water you take should be same in each container.
Yeah.
Okay, right. And here temperature vary. Here temperature will be minus. T is equal to sometimes not minus, sometimes around 18 degrees Celsius. Okay, here 18 degrees Celsius. Normal water, T is equal to 25 degrees Celsius. Here hot water around, okay, let's say T is equal to 80 degrees Celsius. Okay, right. And you take 3 spoon of sugar. Okay, you take 3 spoon of sugar. Okay, 3 spoon of sugar, and you put the sugar into the containers, but the sugar also should be same. Sugar also should be,
Water will dissolve quickly.
yes. In which container the sugar will dissolve easily, quickly?
Hot water.
Hot water, because when temperature increases, the solubility also will increase. If you want, you can write it down in a sentence format. So solubility of a particular substance depends on temperature. Okay, this is a point. Okay,
Yes.
right. Now in the second column they tell 100 gram of water at 25 degrees Celsius. Okay, you take 100 gram of water. Temperature is 25 degrees Celsius.
Yeah.
Okay, now silver nitrate. You take a bottle of silver nitrate. So in 100 gram you can dissolve only 241.3 gram of silver nitrate, AgNO3. So AgNO3 means silver nitrate. Okay, so in 100 gram of water, you can only dissolve 241.3 gram. Okay,
Yeah.
so right now you take 100 gram of AgNO3, 100 gram of silver nitrate. Will it dissolve completely?
What?
Okay, now you take this right maximum amount of silver nitrate that can dissolve in 100 gram of water is 241 gram.
Yeah.
Okay, you take just 100 gram. If you put 100 gram of AgNO3 into 100 gram of water, will it dissolve completely?
No.
Why? Right, you take one beaker. In the beaker you have put some water. Okay, you put
Yeah.
one spoon of sugar. It will dissolve. If you put 2 spoon, it will
Yeah,
dissolve.
dissolve.
If you put 3 spoon, it will dissolve.
It will. Yeah.
After it has attained a certain amount of level, it will not dissolve. If you put 4
Yeah.
spoon under the bottom, you can observe some sugar.
Yeah.
Right. So
It won't completely
right,
dissolve.
this solution is called saturated solution. What is that? Saturated solution. Got the point?
Yeah.
Right. You put 1 spoon, it will dissolve. 2 spoon, dissolves. 3 spoon, dissolves. After putting 4th spoon, you can observe some precipitation of the. It will dissolve further. It will not dissolve further.
Yeah.
Right. So in that case, we call it saturated solution. Okay. Right. Here you can say, if you put 100 gram, will it dissolve completely in water? AgNO3.
Yeah. And it won't dissolve completely.
Yes, it will completely dissolve. You can dissolve up to 241.3 gram of AgNO3 into 100 gram of water.
Why?
Because that's the meaning. Mass dissolving in 100 gram of water at 25 degrees Celsius. Okay, in this case, the maximum amount of spoon of sugars that you can dissolve in this water is 3.
Yeah.
If you put 1 spoon, it will completely dissolve.
Yeah.
If you put 2 spoon, it will completely dissolve. If you put 5 spoon, you can it will not dissolve further. Only 4
Yeah.
spoon will dissolve. The remaining will sink to the bottom,
Stay.
right?
Yeah.
Without dissolving.
Yeah.
Likewise, you can, if you put 1 gram of AgNO3, silver nitrate, it will completely dissolve.
Yeah.
2 gram dissolve, 50 gram dissolve, 100 gram dissolves, right?
Yeah.
241.3 gram. Will it dissolve completely? 241.3 gram.
How will I find that if it will dissolve or not?
Sorry?
How will I find out that it will dissolve or not?
Yes, you can take some amount of AgNO3 and you can weigh it using a balance.
Yeah, I understand, but how will I
Right.
find out that?
Right. After your upcoming grades, you might learn several equations. Using those equations, you can find it out. Now you can just observe the calculated values. Okay. For silver nitrate, you can dissolve 241.3 gram.
Yeah.
Okay. For calcium nitrate, it will be different. It will vary according to substance. Okay. So, but you take. Okay. I will demonstrate. I will. Okay.
Can you tell me the page because I can't see the screen?
Wait. I will try to share the screen. So whenever I start sharing the screen, my video becomes black. That's why.
Yeah.
The page number is. Wait. The page number is, I think, 16 under mixture 2.1 second page. No, 2.1 first page. 2.1 first page.
Yeah.
Right. You got the point. You take same amount of water. Okay.
It will dissolve.
Right. If you put 241.3 gram of AgNO3, it will completely dissolve.
Yeah.
But if you put 242.3 gram,
Yeah.
if you put 242.3 gram of AgNO3, 241.3 gram will dissolve. The remaining 1 gram will precipitate.
Can you say that again?
Right. The maximum amount of AgNO3 that you can dissolve in 100 gram of water is 241.3 gram. Okay, I will tell you using the salt example. Shall I erase this?
Yeah.
Right. You take 100 gram of water. Okay. You take 100 gram of water. 100 gram of water. Okay. Right. In another beaker you have taken 100 gram of water. Okay. In this beaker you put sugar. Okay. You put sugar.
Yeah.
In this beaker you put salt. Okay. Right. Now let's say in 100 gram of water the maximum amount of sugar that you can dissolve is 10 gram. Okay.
10 gram.
10 gram. But it should not be 10 gram for salt. It might be, let's say 8 grams. Okay. So it means in 100 gram of water you can maximum dissolve 8 grams of salt.
Yeah.
Right. Now you put 1 gram of sugar. Will it dissolve completely?
No.
1 gram. It will completely dissolve.
It will dissolve.
2 gram.
Yeah.
3 gram.
Yeah.
5 grams.
Yes.
8 grams.
Yeah.
10 grams.
In this for sugar, right?
Yeah, for sugar.
Yes.
Yes, it will completely dissolve. Up to this point, it will be
Till 10
complete.
gram.
Huh?
Till 10 gram it will come.
Yeah, I add now 10 grams. It will completely dissolve. Now I put 11 grams. Will it completely dissolve?
No, it won't.
No. How many gram will remain at the bottom?
1 gram.
1 gram. If I put 15 grams, how many grams will come to the bottom? 10 gram will dissolve. The remaining 5 grams will come to the bottom. So in this case, if I put 11 grams, I will receive like this. Okay. So this is 100 grams of water and 1 gram will remain. Okay, 1 gram of sugar. So this solution is called saturated solution. What's the term? Saturated solution. Right. Okay, I am just explaining you everything regarding solution. Okay, so that you can easily memorize. In the in your grade 8, you might learn these things because it has not been mentioned in your book. Is it there?
Yeah.
Okay, I will check. Right. I am just explaining. You understood the definition of saturated solution?
Yeah, it's in page number 13.
13. Where? It's mentioned. Okay. Right. Okay. Now tell me, the maximum amount of silver nitrate that can be dissolved in 100 gram of water is 241.3 grams. If you put 100 gram, it will completely dissolve.
Yeah.
If you put 241.3 gram, it will completely dissolve.
Yeah.
If you put 242.3 gram, how many will come to the bottom?
1.
1 gram will come to the bottom. In that case, that is called what? What?
So saturated solution.
Saturated solution. You got the point? So we have studied the definition of mixtures. We have studied what is homogeneous mixture, what is heterogeneous mixture. We have studied what is solution and what is saturated solution. Okay? Like. Now I will share the screen. So, right. Can you see the screen now?
No.
I think you can see now.
I can see now.
What about video now? Video has disappeared?
Share?
Yeah, my screen is shared.
I can see now.
You can see now. Both videos and screen.
Yeah.
Right, very good. This is the table I explained you. Okay, right. So
Yeah.
substance to substance, the solubility may vary. Here for sugar 10 gram, it is not standard values. That's I have explained you. Okay, these are not standard values. For salt 8 grams. Okay. Likewise for silver nitrate, so in 100 gram of water at 25 degrees Celsius, because you need to mention the temperature. Why? Because solubility depends on
The degree.
no, solubility depends on temperature. If you want, you can write solubility depends on temperature. So after this point, you can draw the pictures. I already explained it. Okay, you can take 3 containers. In this container, you take cold water, here normal water, here hot water. So if you dissolve same amount of sugar in hot water, it will quickly dissolve.
Yeah.
So you can.
I'll come take a picture.
Yes.
Done.
Right. Right. Here you can observe silver nitrate 241.3 gram. Calcium nitrate you can only dissolve 102.1 gram. So sugar 91.0 grams. Potassium nitrate,
Calcium hydroxide, right?
yes, calcium hydroxide you can in small amount it dissolves in water. Okay, you can observe what's 0.1113 gram. But calcium carbonate. So calcium carbonate is the chemical formula of chalk. Okay, so chalk, it doesn't dissolve because you can observe 0.0013 gram. So it will, if you put a chunk of chalk, only 0.0013 gram will dissolve. The remaining will come to the bottom. Okay, that means it doesn't dissolve. Okay, right. Now, so silver nitrate is much more soluble than sugar. Okay, silver nitrate is, have they mentioned? But potassium nitrate is a lot less soluble in sugar. So you can compare the solubility. Okay, right. Okay, you are going to compare the solubility. You take silver nitrate and calcium nitrate. But for which substance solubility is high? For silver nitrate or calcium nitrate? Right, now tell me, here solubility high for sugar or salt? Sugar is higher because you can dissolve 10 grams, but here you can only 8 grams. So you can compare solubilities between the compounds. Okay, right. Look at
calcium carbonate is higher.
Yes, calcium carbonate is higher. Look at the calcium hydroxide. It is only very slightly or sparingly soluble. Sparingly soluble means in a very little amount. Okay, calcium hydroxide, in 100 grams of water, only 0.113 grams dissolved. So, very little amount. Sparingly means very little amount. Slightly soluble. So, the synonym of sparingly means, you can write sparingly, synonym is slightly. Okay, slightly soluble. Sparingly soluble.
Sparingly means slightly, right?
Yeah, sparingly means slightly. Okay, right. Look at the calcium hydroxide. It is only very slightly or sparingly soluble. Wait a minute. Right. Yes. Look at calcium hydroxide. It is only very slightly or sparingly soluble. So, sparingly soluble means slightly. It only 0.113 gram dissolves in water. Right? Understood?
Yeah. Can you repeat that again?
Which one?
Can you hear me?
Yes.
Can you repeat that again?
Which one I need to repeat?
I couldn't hear you because your voice was cracking a bit.
Now?
Yeah?
Now can you see? Can you hear me?
I can see now. Yeah.
You can hear me now. Yes. Which one do I need to repeat?
The thing which you said earlier, I couldn't hear.
Which I told. Right. This one you understood. You can compare the solubility of the many substances. Okay. So you can compare the solubility between substances. After that I told sparingly soluble. Sparingly means slightly. Slightly. That's all. Okay. Compare with the compounds above it. It is soluble. Its solution is called lime water. So calcium hydroxide means lime water. Okay. So you need to you are going to be introduced some chemical terms. Okay. Chemical terms. Can I erase?
Yeah.
Right. Here calcium hydroxide. Calcium hydroxide means this is lime water. lime water. So chemical formula is like this: calcium hydroxide. Okay, you can write it down separately. We will study the use of
hydroxide. What's the down?
lime water. We call calcium hydroxide as lime water. Likewise, we call ethanol as alcohol. Likewise, calcium hydroxide is called lime water. Right? Both are the name of this part, calcium hydroxide. So normally we use this calcium hydroxide to identify carbon dioxide. So if you pass carbon dioxide through calcium hydroxide, it will turn to milky color. So when you do chemical practicals, you will use it. So we will study later. Okay, you just write this down: calcium hydroxide, lime water. This is the chemical formula. So if you want, you can write. It is used to identify CO2 gas. These are notes. You don't need to bother about whether it has been included in your syllabi. You should know these things.
Can you write that note again?
Yeah. Lime water is used to identify CO2 gas. When CO2 is passed through lime water, it will turn to milky color. Okay, you can just remember. So when you study in your upcoming grades, you might refresh. You can just refresh without much effort. Okay. I will teach you some extra points as well. I don't need to read your textbook and explain you. I will just tell you some extra points. Do you want to see any videos regarding this practical?
Hello?
Yes.
Your voice is
Why? Now okay? What about now?
Yeah?
Now okay?
Yeah, now okay.
Right. You wrote it down.
What?
Did you write it down?
Yeah.
Okay. Right. This practical is maybe available on YouTube. You can just see. Otherwise, do I need to see any videos?
Can you send me the video? I will see.
Okay, I will. Okay, it might be interesting. Okay, so when you get free times, you can just observe. Calcium water will be like water, just water. So when you pass CO2 gas through the lime water, it will become milky color. So in chemistry, there will be several interesting things. You might learn them. Okay, little by little. Okay, right. Now look at the last two substances in the table. They are usually called insoluble, since so very little dissolved. Okay. Now substances can be divided as, okay, normally silver nitrate is soluble. Calcium hydroxide is sparingly soluble.
Yeah.
But silver chloride is not soluble. Not soluble means insoluble. Okay, so we have introduced. Shall I erase this portion? Right. We have learned three terms. What are they? Soluble in something, in water or something. Soluble. Second one, sparingly soluble. Okay, sparingly soluble. The last one is insoluble. Insoluble means it doesn't dissolve. Insoluble means it does not dissolve. Okay. So some substances are soluble. Some substances are sparingly soluble. Some substances are insoluble. It means it does not dissolve in water.
Yeah.
Okay. Right. Right. Here, what's soluble, what's not. The solubility of every substance is different. Do you agree?
Um,
The solubility of every substance is different. Normally, sugar and what? Salt. Okay. But there are some overall pattern. But you can compare the solubility using a pattern. For example, all sodium compounds are soluble. If you take sodium chloride, what is sodium chloride? Do you know sodium chloride?
sodium plus chloride.
Sodium chloride. This is a compound. So, where can you find sodium chloride?
Like in mineral.
Yeah. You can simply use. You can simply
Rock. In rock.
in rocks, but here salt, kitchen salt. In kitchen salt also there is sodium chloride.
Yes.
Okay. So, right. You are putting salt means you are dissolving sodium chloride.
Yeah.
Right. Likewise, you can all sodium chloride, sodium fluoride, sodium bromide, sodium nitrate, all sodium compounds are soluble in water. You can find it out in page number 160. Shall we go to this page?
Yeah. In page number 160, there are only questions.
Wait, I will show you.
No, it's a revision checklist.
I think your edition is different from mine, so that's why.
No, it's a revision checklist, not question.
Okay. I will go to that. I will go to that page and let you know.
It's page
Normally, your examination questions are taken from your book. Okay? Is that so? You will not be asked any external questions. Am I right? In your examination are questions taken from your textbook.
mainly from book, but a bit different question.
Okay, with different questions. But they will test all the theories that they taught.
Yeah.
Where is the 160th page?
A little like
Some different questions. Okay, that's not an issue. We will study. After completing the chapters, we can do some past papers, right?
Yeah.
So we have to hurry up. We have to finish quickly. When will your second term examination be held? Yeah. Right here.
February first week I have internal exam.
February.
In March I have second term and February first week I have internal.
For internal, what chapters should you study? Right.
This didn't send the portion.
Right here, making insoluble salt by precipitation. You already know what is precipitation. Some amount of solute will remain at the bottom of the beaker or the container. So that is called precipitation. So making insoluble salts by precipitation. Not all solutes are insoluble. Not here.
Which page is this?
160th page. I think you have third edition. I have downloaded second edition. So it might be different.
Third edition.
Yeah. You can just see my screen. If you want, you can take a screenshot. Not all salts are soluble. The salts we looked at so far have all been soluble. You could obtain them as crystals by evaporating solutions.
I have this one in page number 153.
Okay. You can see that. Do you need to study 11.7 for the internal examination?
One.
It's a little bit advanced, so I can skip it.
It's in syllabus. I send you my second term portion, right?
Yeah. Is it included in your internal examination syllabus? 11.7, can you check and tell me?
They will include the things which I learned, like all the things,
Sorry?
until exam. The things which I learned until exam, they will include all those. I'm not sure about
11.7. You have a chapter allocation for your term examination.
I send you.
Yeah, you can check whether it.
The second term portion.
Yeah, you check. You send me. But can you tell me whether you need to study this 11.7 for your second term examination? Just observe and tell me. Otherwise, I can skip it.
Yeah, 11.7 is not there.
It's not there, so we can skip it.
Yeah.
Okay. We need to study that part also, but we have to get more marks in the examination also. We need to cover all the chapter allocation for your term examination. Okay?
Yeah, what did you say?
We have to study the complete book so that you can get a better understanding of chemistry. Okay, but we need to concentrate on this chapter allocation as well, so that you can get more marks in the examination, because they will take question from the chapter allocations, no?
Yeah.
Okay. Wait. Page number 60. What's the page number? 60.
160.
20?
160.
No. 1.2. 1.2 or 2.1? What were we discussed? Right. We have finished this one. Now, helping a solute to dissolve. What is solute?
Solute.
I introduced two terms. In a solution, there are two components. What are they? You should not confuse with.
Solution.
A solution contains two components. What are they?
Solution component. They are.
What are they?
Insoluble and soluble.
No. Here, substances can be either soluble, sparingly soluble, or insoluble. This is another chapter. I told in a solution,
Yeah.
you might take a solvent, and you might dissolve a solute. Okay, so solvent solvent, dissolve, solute. You should not confuse with solute and solvent. Both are different terms.
Solute contains three things, right?
Yeah. Solvent may be.
Solid and ink.
Yes. Solvents are usually liquid. Okay. But solute can be.
I can't open this one.
Sorry.
1 minute.
Okay.
Yeah.
Right. Here, solvent is usually liquid. Okay.
Yeah.
But solute may be solid, liquid, or gas.
Yes.
Okay. You should remember these things. You should just refresh again and again. And you should not confuse with these terms. Solute is completely different from solvent. Solvent dissolves solute, but solute is dissolved in solvent.
Yeah.
Okay. Right. Now we are going to help the solute to dissolve in the solvent. Okay. How can you help? You just have. Now you are going to help the solute. Okay. Let's say you take a water in a beaker. Some water in a beaker. Okay. You are going to add sugar. So sugar is what?
Sugar is the solute.
Solute. Water is
Solvent.
solvent. Now you are going to make this sugar dissolve quickly. So that's what they have mentioned, helping. You are going to help this sugar to dissolve in this water. What measures do you can take? Can you take?
Like a maximum amount.
No. Up to which? Right. Can you tell me some ideas how you can help the sugar to dissolve in water using whatever we have studied so far?
By using separate method.
Yeah, you can use some methods. What can you do? You can just increase the temperature. If you increase the temperature, it will
dissolve.
it will dissolve. Right. Have you ever observed your mom when she prepares tea?
Yes.
What will she do when making tea? She will stir.
Yeah.
So why does she stir?
To dissolve.
Yeah, to make the sugar
particles.
dissolve in the water. Okay.
Yeah.
So she will use hot water to make tea. So already she has helped. Again, in order to make this process more quickly, she will stir. Okay, stir. Right. So that's what they have mentioned here. So helping a solute dissolve, stirring rod. Okay, stirring rod. If you use a stirring rod or spoon to stir the solution, it will dissolve quickly. Right. And she will use temperature. She will increase temperature. Means heat. She will heat. Okay. She will heat. Okay. You can see here. Sugar dissolves quite slowly in water at room temperature. It will dissolve, but very slowly. When you increase temperature, it will happen quickly.
Automatically.
Okay. But if you keep on adding sugar, extra sugar sinks to the bottom. Eventually, no more of it will dissolve, no matter how hard you stir. Right. After it has attained the saturated level, even if you stir, it will not dissolve, because what is that? It is saturated solution. Right. After adding there is a capacity. 100 gram water. In 100 gram water, you can dissolve only 10 grams of sugar. After adding 10 grams of sugar, even though you stir the solution, it will not dissolve. But look what happens if you heat the solution. Extra sugar will dissolve. Add more sugar and it will dissolve. Right. After,
Green share.
yes. Can't you see my screen?
Right now it's showing black. The screen. After I touch.
Okay. You can observe you can see your book. Okay. Right.
I
But
think it's sharing now.
it's being shared now.
Give me a minute.
Shall I continue? Shall I continue?
It was stepped a bit.
Right. Screen is not necessary. Can you see my board?
Wait.
Can you see my board?
I can see now.
You can see now. Right. Now let's say in 100 gram of water you can only dissolve 10 gram of sugar.
Yeah.
Now you have added 15 gram of sugar. How many will remain to the bottom?
I will add 15 gram of sugar, but the maximum amount is 8, right?
No, 10. I'm adding sugar.
5.
5. But now my aim, right, 5 gram remains. Okay, 5 gram of sugar remains. Even if I stir, it will not dissolve.
Yeah.
But my aim is to dissolve that 5 gram as well. What will I do? I will increase the temperature. So when the temperature is increased, the solubility will increase. That means the amount of substance that you can dissolve will increase.
Yeah.
Okay. So if I increase the temperature, this 5 gram also will dissolve. Okay. Okay. Now you understood. So for increasing the solubility, what will you do?
I will to increase the solubility. I will.
There are two cases. You are going to help dissolve more quickly. You have to understand the big differences. Helping and increasing the solubility are different. To help the solute to dissolve quickly, you will stir. Okay.
Yeah.
But in order to increase the solubility, that means if you want to add more, if you want to dissolve more solute, you need to increase the temperature.
Yeah.
Okay. Right. No sugar is more soluble in hot water than in cold water. A soluble solid usually gets more soluble as the temperature rises. Okay, you understood that. A solution is called saturated when it can dissolve no more solute at that temperature. Okay? Right. Right. You can just draw like this. If you draw like this, you can understand everything without writing notes.
Can I take a screenshot?
Yes, sure.
Yeah.
But after completion of each class, you have to revise whatever we study in the particular class. Otherwise, you will forget. That's very important. Your self-study is very important. Okay? That's why I am not going to conduct your classes every day.
Yeah.
Hereafter, I have sent you a timetable. So we will study according to that timetable. So in the remaining days, you should study alone. Okay? Will you study?
I
No. Still you can't hear my voice?
Hello.
What about now?
Your voice is very low.
Now? Now?
Hello.
Now?
Yeah, now.
Now okay, right. Right. What I told is, when I go far away from the device, you can't hear my voice, right?
Yeah, it's low.
Right. Right. Your self-study is very important. That's what I told. Okay. Hereafter, we will only join via Zoom according to the timetable I gave you. We will not conduct classes every day. So in the remaining days, you should study alone. So whenever you have any doubts, you can interrupt me at any time when I will explain you. Okay?
Yes.
But you should study every day. But I can't observe whether you are studying or not. Your mother will observe. But you have to have a passion. What is your ambition?
Doctor.
Doctor. So in order to become a doctor, so you should study every day. Okay? Right. Water is not the only solvent. Okay. They tell we have so far we have dissolved solutes into water. But is water only the solvent?
Yeah.
Is only water the solvent?
No.
There are several solvents. Okay. So water is the world's more common solvent. Water is common solvent. Okay. Water is common solvent. A solution in water is called an aqueous solution.
Yeah.
So, okay. From aqua, the Latin word for water. So aqueous
Aqua is the
solution.
Latin word.
Sorry.
Aqua is the Latin word.
Yes. Aqua is a Latin word. Aqua is Latin word. The meaning of aqua is water. So water is an English term. Water is English word. And aqua is Latin word. Okay. So they tell water is the world's common solvent. A solution in water is called an aqueous solution. Okay. A solution in water. A solution in water is called aqueous solution. Aqueous solution. Aqueous solution means a solution in water. There will be water. Okay, right. But many other solvents are used in industry and about the house to dissolve substances that are insoluble in water. If a substance is insoluble in water, it may be soluble in other solvents. For example, HCl. So HCl is a liquid. Okay, HCl, you know HCl. What is HCl? Have you heard this term HCl? It's a compound, but HCl is an acid. HCl is acid. Okay, so HCl is acid. So you are not going to dissolve sugar into acid. You are just going to put some iron or magnesium, sodium. Right? What will happen if you put sodium into HCl? Sodium. It will go around with a sound. Okay. Have you demonstrated in your laboratories? Okay. Yes. So you take HCl. So here HCl acts as a solvent. Okay. Right. Here they have given some examples and the
in the left they said like because of second term they will start because I'm not going to physical school they will start from Monday so maybe that time they will take it.
Sorry, I didn't get you.
Second term physical school didn't start yet because till now I had online school so from Monday I will go to school.
Okay.
I think in that time they will show.
Yeah. So after going to school in person, they will demonstrate everything in your laboratory. Yeah. If you want, you can just type on YouTube. Right.
And then it turned into
Yes, if you want to see the video, I will share the link. Otherwise, you can just go to search bar of YouTube and type sodium reaction with HCl. If you, yeah, you may see, because everything is available online nowadays. Right, solvent, it dissolves. Right, white spirit, gloss paint. So white spirit means it's like an alcohol, so it dissolves paint. Okay, propane means acetone. This is also an organic compound. This propane, in this propane you can dissolve grease or nail polish. So if, right, you have applied nail polish on your nail, okay, now your miss has blamed you for applying it. So you want to remove it. How will you do that? Right, nail polish remover. So in that nail polish remover they have added propanol, acetone. Not ethanol, propanol, acetone. So you can, in your nail polish remover, you can read. So in the contents they might include propanol. Okay, you can just observe if you have nail polish remover. Okay, so ethanol. Yeah, so right, propanol. So propanol dissolves grease. So when your hands are ugly with grease, you can just put that nail remover, nail polish remover as well, so that you can get rid of the grease. Okay, right. Now ethanol dissolves glues, printing inks, the sealed substances that are used in perfumes and aftershaves. Okay, so these are for your, right. So right, you have, right, in your hand you have some glues, so you can just apply ethanol. Right? Okay. These are the applications of chemistry. After studying chemistry, you have to know these things. So when a friend of yours asks, hi, I have some nail polish on my nail, I want to remove it, what will you do? You just go to laboratory and take some propanol and apply it on the hand. Propanol. But you should be very careful when handling chemicals. You should not go to laboratory without the surveillance of a teacher. Okay, you can just use nail polisher. Okay, in that nail polisher they have included propanol. That's what I want to say. Okay, right. All three of these solvents evaporate easily at room temperature. So these solvents are organic compounds. So these are volatile compounds. Volatile means it may evaporate. So if you open the bottle, it may evaporate, right, at room temperature itself. They are volatile, right, they have mentioned. They are volatile. Volatile means they have the tendency to evaporate. Right? So is this term new to you? Volatile. Right. You should write the definitions or meanings. Volatile means it may evaporate in your book, or else you can write it down separately. And you should refer. Sorry?
It's written over here, volatile.
Yeah, here they have mentioned everything. Yes. This means that glues and paints dry easily. Aftershaves feels cool because ethanol cools the skin when it evaporates. Okay, when it evaporates, how it evaporates? Okay, have you applied scent on your hand? Scent or cologne?
Yeah.
Right, what will you feel?
I can smell the.
Okay, you can smell the perfume. You can smell the fragrance. What else? You should think. What else? Your hand will become cool.
Yeah. And I can also see the mask.
Sorry?
Yeah, it will spread.
Yeah, it will spread and your hand will become cool. So why does it become cool? After that, it will evaporate. It will evaporate. Once you applied the cologne on your hand, it will evaporate, and your hand will become cool. Right? Why does it become cool? Because it, yes, because it gets heat from your hand. Normally, in your body, you have heat around 27 degrees Celsius. So it takes heat from your body. So that's why you cool. You feel cool. Okay, so this means that glues and paints dry easily. Aftershaves feels good because ethanol cools the skin when it evaporates. So when it evaporates, if something wants to evaporate, okay, you boil a beaker of water. Okay, so when it evaporates, the container takes energy from the heat source. It may be Bunsen burner, it may be a rice cooker, whatever it may be, it takes heat from the heat source. After getting the heat, it evaporates. Okay? Do you understand what I am telling? Hello? Am I audible? Am I audible?
I can hear. Your voice is low when you go to the microphone.
Oh, okay. Bye. What about now?
I can hear now.
You can hear now?
Yeah.
Right. Shall I erase this? Right. Here, I am heating a container of water using a Bunsen burner or something. So, the container gets heat from the heat source and it evaporates. So, when it evaporates, the water will become as gas.
Yeah.
Right? Likewise, I am applying in this, let's say it is hand. Okay, I am applying some perfume.
Applying what?
Perfume.
Yeah.
Right. So once you apply perfume, it will evaporate. Okay.
Yeah, it's good.
It will disappear. It will disappear means it evaporates, and you will feel cool. So why you feel cool is the energy that is required for the evaporation is taken from your body.
Yeah.
So that's why you cool. You feel cool. Okay.
Yeah.
Right. Now about volatile liquids. So some liquids are volatile. For example, can you tell me an example for volatile liquid?
Um,
Perfume.
the homework which you like. 1 minute. Example for volatile.
Not example for. You can see my screen, right?
Screen, it's appearing black. When I click that screen, it's coming black and then it's turning on.
I think your device has some issues.
Yeah, I can see now.
Right. About volatile liquids. Can you tell me some examples for volatile liquids?
I can't see your screen. I can see the video. Yeah, I can see now. About volatile liquids.
Right. Can you tell me some examples for volatile liquids?
Volatile. Perfume.
Ethanol.
Water.
Oh yeah, water is also volatile. Okay, it's also volatile, but
Honey.
honey is not volatile because when you keep honey, it will not disappear. Will it disappear?
No.
No.
Hot water.
Water is also okay, right? Like you are washing some clothes and you keep the clothes in the sunlight, so it will evaporate.
I see.
Right. You seen the water cycle? In water cycle, evaporation occurs. Evaporation from the sea area and river area, water goes to the atmosphere.
Yeah.
By evaporation. So water is also a volatile liquid, but not that much. But it perfume will quickly evaporate, but it will take a certain amount of time for evaporating the water.
Yeah.
Okay, the volatile liquid is one that evaporates easily. So you can't say water is volatile because it takes a lot of time to evaporate. But volatile liquid should evaporate easily. Every liquid, even water evaporates. Okay, when you heat the water, it will evaporate, but it will not easily evaporate. But if you open the perfume bottle, it will evaporate.
It does.
So to avoid evaporation, you should close the perfume bottle.
Yeah.
Right. So volatile liquids is that evaporates easily. So that is very important. If you want, you can highlight it easily.
Yeah.
Okay. This is a sign that the forces between its particles are weak, because this is the sign the forces between its particles are weak. So why does it evaporate? Because in each liquid there is a force or attraction. So
Yeah.
if the attraction is very low, it will evaporate.
Yeah.
Okay. Okay. Let's say here they have two people. Okay. Here they have two people. Right. Here they have a strong interaction or attraction. Here they don't have a much attraction. So they can separate it. And we likewise I'm just explaining using an example. So when the forces mean interaction between the particles is weak, it will evaporate easily. So in this perfume, the forces between the perfume molecules are very weak. So that's why they evaporate.
Yeah.
Okay. So volatile liquids have low boiling points too. Okay. So volatile liquids have low boiling too. Boiling means even if you give a small amount of energy or heat, it will evaporate. So the boiling point is very low. So this is an important point. You should remember. Right? For volatile liquid, for volatile liquid, boiling points is very low. But boiling point is very low, very low. Even if you give a small amount of energy, it will evaporate.
The board is not clear.
Board is not clear?
I can see the board, but the letters are disappeared. Can you write it a bit big?
Right. Here, for volatile, now you can see. What about now? Now is it okay? Is it okay now?
Oh, I was muted. Can you write it a bit big, like the letters bigger? Because the board is clear, the letters are like big. They are not clear.
Right. Volatile liquid. For a volatile liquid, the boiling point is very low. What? Boiling point
Boiling point
is very
very
low.
low.
For example, what is the boiling point of water? What is the boiling point of water?
What did you write over there? Because they are like not clear. I want to take a screenshot. Can you? What is written over there?
Volatile liquid. Okay, here volatile liquid. Okay. For a volatile liquid, boiling point is very low. That's what I
The
have
letters
written.
are shining. I can't see. it's like blur.
Now also,
It's the same.
it's the same. Okay, okay, okay. I don't want to write it on the board. I will just explain it. Okay. Right. Can you tell me? Can you tell me what is the boiling point of? What is the boiling point of? Boiling point of water. Do you know the boiling point of water? At what temperature does water boil?
It's 100 Celsius. Right?
Boiling point. So for water, it's 100 degrees Celsius. Okay, 100 degrees Celsius. But for propanol is a what? Volatile. Propanol is a volatile liquid. For propanol,
Liquid.
it's 56.5. For propanol, it's what? 56.5.
6.5.
So you can observe here. For water is not volatile. Do you agree?
Yeah.
But propanol is volatile. So for propanol, it's
Why water is not volatile? Because it evaporates easily.
yeah, it evaporates, but it does not evaporate easily.
It does.
Yes.
It's turning into hot water, right? So
Yes, I already told you. Volatile liquids is one that evaporates easily. I told you to highlight this easily. Does
Yeah.
water evaporate easily?
uh,
Like perfume?
water it evaporates easily because it's turning into hot water, right?
Yeah, no, it's not easily. If you give 100 degrees Celsius only, it will evaporate.
Yeah.
Okay, okay, I will explain. You take two containers, right? You take two containers. In this container, you have water. Okay. This is a perfume box. Okay, perfume bottle. Right. If you keep this water bottle and perfume bottle open, okay, open, the water will evaporate, but very slowly, very slowly. But perfume will easily evaporate. Perfume will easily evaporate. Okay.
Okay.
Now this perfume is called volatile, but it is not volatile because it does not dissolve easily. The key word is easily. Easily evaporates. Okay.
I can you like I can't see the board. I can see the board, but I can't see anything like the letters. They are blur.
What about now?
No, it's the same.
Still it's the same?
Yeah. I can see the board, but the letters are like light and shining.
Letters are shining.
Yeah.
Okay, I will tell you. Okay. You just observe me. Here, in this hand, I have a water bottle. Okay.
Yeah.
In this hand, I have a perfume bottle.
Yeah.
I have kept both bottles open. Okay.
Yeah.
Okay. Both bottles are open. Here, in the perfume bottle, the perfume will easily evaporate.
Yeah.
But the water bottle will remain same. It will not dissolve, evaporate. If it evaporates, you can't drink water. Can you drink water? Before you drink, it will evaporate.
Yeah.
So the key term is the volatile liquid is one that evaporates easily. So what substance easily evaporates? Water or perfume?
Perfume.
So perfume is volatile, but water is not volatile.
Yeah.
Okay, now you take propane bottle. So if you open the propane bottle, it will easily evaporate. So propanone is what? Okay, you have nail polisher remover. Okay. At
So
home.
perfume evaporates easily.
Sorry.
Perfume evaporates easily, right?
Yes, perfume evaporates easily. So that is called what? Volatile liquid. But water does not evaporate
I want to
easily.
take a screenshot of the thing which you wrote in board. Can you?
Okay, I will take a photo and send you. Okay.
Okay.
Okay. Right. What I am stressing you is the key term is easily. Okay. You have water
Yeah.
and perfume. Perfume will evaporate easily.
Yeah.
But water does not evaporate easily. It will take a certain amount of time. So water is not a volatile compound.
Yeah.
Okay. But if you take propane, okay, you take the nail polish remover. You keep it open. What will happen?
First,
Okay. You have nail polish remover at your home. Do you have?
yeah.
Right. You
Yeah, I
take
do.
some amount of nail polish remover. Okay.
Yeah.
So when you keep
Yeah.
it open, it will evaporate easily.
The nail polish remover?
You can demonstrate it. Right. You apply some nail polish remover. Once you apply the nail polish remover, will it stay?
Yeah.
After a few minutes, it will disappear.
Yeah, it will disappear.
So it means it evaporates. But
we can also use nail polish remover to remove nail glue, right?
But
We can also use nail polish remover to remove nail glue, right?
nail?
Because it's pepper nail polish
Your voice is cracking.
remover.
Am I audible to you?
1 minute. I can hear you clearly. Can you hear me?
Your voice is breaking. Okay, you can just message me what you asked. I will explain you. And after explanation, I will finish the class. Okay?
Hello, can you hear me?
Yes, tell me.
We can also use nail polish remover to remove a nail glue from our nail, right? Because it's propanone.
Yes, it's propanone. Okay.
So it will also remove nail glue.
Nail glue. What is nail glue? I don't know. Nail glue means?
Propanone means. Can you tell me what is the different definition of propanone?
Right. Propanone means like this. You can't see the board, right? Right. You know
No,
glucose.
it's not
Glucose is what? Organic compound. Okay?
Yeah.
I wrote C6H12O6. Likewise,
For nail
propanone.
polish remover, acetone is used, not propanone.
Acetone?
Acetone is used, not propanone.
Yeah, both are same. Acetone and propanone are same. Like lime water and calcium hydroxide. Both are same.
They both are same?
Yeah, propanone and acetone are same. Here you can see propanone, they have given acetone in brackets. Can't you see? So propanone is IUPAC name. It is industrial name. Okay. You understand?
Okay.
Like propanol
Yeah.
and acetone are same. Like we already studied. Lime water and calcium hydroxides are same.
Yeah.
Right. Likewise, propanol and acetone are same. Now what I am telling is, you take in this hand, you pour some amount of little amount of water. Okay.
Water?
Water.
Okay.
Right. In this hand, you put some nail polish remover,
Okay.
which will evaporate easily.
I will try. Water.
Water.
No, not water. The nail polish remover.
Okay. After finishing the class, you take some nail polisher. You pour some nail polisher in your hands or in your nail.
Yeah.
Have you ever removed nail polish using that remover? One time. Do you have experience, right? So once you apply the nail polish remover, it will disappear. Will it disappear?
I tried it. The nail polish remover is evaporating faster.
Sorry?
I tried the experiment. The nail polish remover is evaporating.
Okay. So nail polish remover easily evaporates, but water does not easily evaporate. I am stressing the word easily.
Yeah.
Easily.
Because
So a volatile
it
liquid
stays
is.
in the same place continuously.
Yes, likewise, propanol. You can go to the laboratory. You take some propanol. You open the lid. Once you open the lid and keep it open, it will evaporate.
Yeah.
It will easily
Yeah.
evaporate. If it is easily evaporating, it is called volatile liquid. For volatile liquid,
Yeah.
boiling point is very low. So you can observe, water is not volatile.
Yeah.
Water is not volatile. But propanol is volatile.
Yeah.
Right. But if you compare the boiling points, 100 is bigger than 56.5. So for a volatile liquid, the boiling point is very low. Okay?
Yeah.
Right. With that, I have completed 2.1. You can try these questions. Okay? And send me the answer. And I already gave you a homework, but you have not submitted the answer. When will you submit? Now you need to try these questions. Okay, these questions. Can you see the questions in the screen?
Yeah, I can see the question.
So there are 6 questions. You have to try all the questions. Then only you can assess yourself. Okay.
I have to do these questions as well because I have to do the assignment. I have to complete assignment register 2.1, 2.2, and 4.1.
Okay. Whenever you have free time, you can write it and send me. I will correct it.
Yeah, because Miss said that she will check our assignment registers tomorrow, so I have to complete them by today.
Which one?
The assignment register which I sent you earlier. I will do it on my own because after finishing this step.
You are doing the assignment. Okay. After doing that, you will do the questions, like my homeworks.
Yeah.
Okay. You can take your time because
What?
we will meet on Friday next. Okay.
I didn't understand. What did you say?
Sorry.
What were you saying? I couldn't hear.
Right. You have an assignment to be submitted in your school.
Yeah, tomorrow.
So, okay. You do the assignment. After doing the assignment, when you have free time, you can do the questions.
Yeah, I will.
Okay.
Because the same questions are in the assignment register.
Okay. So then you don't need.
They are putting the same questions in the assignment register as well.
Okay. You don't need. So you don't
But
need.
some questions are different. But
Okay. When you have
some of
doubt, you
them are
can ask me.
different.
Okay.
But
When you have doubt, you can ask
mostly-
me. And you study well. We will meet.
because I am going to do the assignment register after this class. If I don't understand, because there is one more question, like they are giving different question, not from the book. So can I send you the question?
Yeah, I have told you to do this question. You can see the screen.
Yeah. No, I was saying that in the assignment register they are giving the similar questions, but one or two questions are different. If
Okay.
I don't understand, can I send you the question? Can you tell me the answer?
Yeah. Okay.
I will try.
Okay, you try. If you don't know, you can ask me. I'm always here to help you.
Okay.
Okay.
Thanks.
And we will meet on Friday. Okay?
Thank you very much,
Okay.
sir.
You can leave now.